This video is going to cover parallel lines and transversals, so let's go ahead and get started. The first thing I want you to do is kind of compare and contrast these two images. Just take a second and think about what is similar and what is different. All right, so a few things that I want to point out is some of the things that are similar. First, I noticed that there are 8 different angles in both diagrams marked. I noticed that that's because I have 2 lines that are cut by one other line. Same thing in this diagram. I have 2 lines that are cut by another line. Do you guys see any other similarities? Those are the ones I want to point out, but let's look at what's different. Now, one of the main things that I want to focus on in what is different are these 2 lines in both of these diagrams. Now, I'm going to start by focusing on this diagram right here. If I were to cut these 2 lines in half, this one line in half, and have these 2 different sections, I'm going to draw a complete line, and have these 2 different sections. I like to call them 2 different intersections. Here's intersection 1, and here's intersection 2. If I were to take intersection 1 and pick it up and slide it down to intersection 2, notice that they would line up perfectly on top of one another because this line and this line are parallel. Now, does the same thing happen on my other diagram? If I were to cut my diagram in half into 2 intersections, here's intersection 1 and here's intersection 2. If I were to pick up intersection 1 and slide it directly over, does it perfectly line up on intersection 2? And you can see that it doesn't. This angle 4 is smaller than this angle 8. And the reason why this one doesn't line up perfectly is because this line and this line are not parallel. So this relationship that I see between intersections occurs when lines are parallel. Let's look at a different diagram. So if I were to for example, take another diagram, cut it into my 2 different intersections, intersection 1, intersection 2, and I were to pick up and slide this down on top of the other, you can see that this red part of the diagram is going to line up with this red part of my diagram. My blue is going to line up with the blue, green with green, and black with black. Now, these matching angles, we are congruent, and we call them corresponding angles. So I'm going to say that a couple different times again today, but if I were to pick up and set it down on top of the other each intersection on top of the other intersection, so intersection 1 on intersection 2, if they line up right on top of each other, they're called corresponding angles. And it doesn't matter what diagram I look at, so you can see here's intersection 1, here's intersection 2. If I were to cut them my lines right here, because these lines are parallel, I can pick up intersection 1 and set it directly on intersection 2, and you'll notice that all of the angles, the 2 angles marked in red are the same size, the 2 angles marked in green are the same size, in blue and in black. And those matching colors, which we call those matching angles, are congruent. They're the same size. So if I were to look at a diagram, okay, let's look at example number 1, and I see this 2 intersections, intersection 1 and intersection 2, and I was to cut that in half. Notice that when I slide this over here, pick it up and slide it, this angle right here matches this angle right here. So if I was to use this diagram and find the measures of the numbered angles, I could right now, I could right now say that angle 2 is equal to 65 degrees. In fact, I could find the measure of all of my angles. Let's go ahead and let me show you how I do that. Remember that, and I'm going to use a different color to separate my diagram. So we're going to cut our diagram in half. Remember that fact about vertical angles. When two angles, so let's look at this intersection here. When this angle and this angle, which only share a vertex, those are called vertical angles, and they are congruent. If I were to fold along that line right there, they'd line up perfectly. So this angle and this angle are vertical angles. Notice if I were to pick up and set down my intersection, that this would slide right here. So this is also 65 degrees. Now, if I wanted to find any of the other angles in my diagrams, I need to remember a special fact about lines. Remember that straight lines, here's a straight line, these are called a linear pair or supplementary. They form 180 degrees. Whenever you see a straight line, it forms, whatever two angles I have form 180 degrees. So how do I end up with this portion if I know that this smaller portion is 65? Remember, I can, with my calculator, 180 minus 65. And as I type that into my calculator, I'm going to end up with 115. So this angle is 115. Now, what can I do to fill in the rest of my diagram? And I'm going to erase this line because it's hard to see. Remember, because I have these two parallel lines, I can pick up my intersection and slide it over, and this angle right here, which is 115, is going to land on this angle right here, which is 115. And how do I finish? Remember, these are vertical angles because they only touch at my one intersection point. So this is 115, and when I slide my intersection over, this is 115 as well. Okay, big overall idea that I want you to see. Notice what the degree measures of all of my angles I have written are. They are either 65 or 115. That's all that there is. Notice 65, 65, 65, 65, 115, 115, 115. And the other thing I want you to kind of notice and pay attention to is notice how these angles alternate. 65, then 115, then 65, then 115, then 65, then 115, then 65, then 115. And this pattern is going to happen again and again. And notice what happens when I add any two 115 and 65s, they total 180. So this diagram has got a lot to do, a lot of similarities. Let's look at example number 2. Here's intersection 1, here's intersection 2. If I were to divide my intersections right here and slide it, remember 74 is going to land right here where this angle is, so 74. Well, let's practice filling in the rest of this diagram. Remember that my vertical angles, the ones that touch only at the intersection, okay, vertical angles, they only touch at this intersection, also 74. And if I were to slide my intersection over, these are to line up perfectly, 74. And how do I get the remaining 4 angles? Well, this forms a straight line right here. So 180 minus 74 is a grand total of, 180 minus 74 is 106. So this is also 106 because they are corresponding, that vocabulary word, corresponding, when I pick up and set it down on top of each other. And remember the pattern. My angles are only 106 or 74. So 106 because these are vertical, and 106 because these are vertical. And that is how I find my missing angles on a diagram. Again, notice the pattern, 106, 74, 106, 74, 106, 74, 106, 74. Now, does this work on diagrams? If I go back, does this work on this diagram right here? Does that rule work? Now remember, if I have my two intersections, they have to be, these two lines, line 1 and line 2, have to be parallel. Because when I slide this over, number 1 does not slide directly onto intersection number 2. This line does not match up with this line. One that's just like your assignment on your homework. So it says, two lines are parallel, cut by a transversal as shown below. So here's intersection 1, here's intersection 2, and they line up perfectly. If I slide one, it lands onto the other. So angle 1 lines up with angle 5, angle 2 lines up with angle 6, angle 8 and angle 4 line up, and angle 7 and angle 3 line up. Let's look at calculating these. Suppose measure of angle 8 is 136, pardon me. Label that in there. So automatically, what other angle is 136? This other angle marked in red, it's corresponding angle 136. Because remember, if I slide my intersection, my parallel lines are going to line up and it's going to be perfectly equal. Congruent, we call it. Our vertical angles are also the same. So 136, these are vertical angles because they touch only at this intersection point. And how do I find my remaining? Okay, remember my straight line adds to 180. So with my handy dandy calculator, 180 minus 136 gives me 44. Okay, remember by default that means my vertical angle here is 44 and the matching angles, corresponding angles, so if I were to pick up and set down on my other intersection, are going to be the same. So answer the question, what is the measure of angle 1? Well, angle 1 is 44 degrees. And what's the measure of angle 3? Also 44 degrees. And again, notice that all my degrees are adding to 180 and they alternate. All right, if you have any questions, please reach out to your teacher.